Okay, so in today's class, what are we going to discuss? We are first going to discuss different applications of differential equation, right? मतलब in general in mathematics you will not find this as a JEE Advanced syllabus, right? Is it clear? But in physics part, definitely you are going to find various application of differential equation. Even in mathematics, you have determined one quantity, that is tangent of curve and normal to the curve, and all those things you have determined, है ना?
Yes.
So in today's class, we will try to study what are the application of first order differential equation only. Is it clear? In upcoming classes, I will be teaching you the application of second order differential equation also. So, for the beginning, we will do this. First application is here, you can say geometric application. Okay, the application related to geometry, and we will be studying here about this system. It is a Cartesian coordinate system, x and y axis with 0, 0 here. Okay, now what we are trying to discuss is, suppose there is any function or a graph like this. Okay, it will be a random graph. Consider the equation is fx comma y, right? So this is a random curve, any curve. Okay, therefore at any point P, let's say this is point P, and say the coordinate of this point is x comma y. Then if you want to determine tangent at this point, then how would you proceed? So here I will be telling you tangent at point P, which is very easy, right? First of all, to determine the tangent, you will have to determine slope of the tangent, right? So at this point, tangent is this line to be effective, right? And to make the equation of line, you require at least two things. One is one point, which is x comma y, and another one is slope of the line, है ना? Yes, and slope of the line will be given by dy by dx, right? This is equal to slope, which is equals to m, and which is equals to, if I say this angle is theta, this is also equal to tan theta, right? Is it clear? So as soon as you see your equation in x and y, you do the differentiation with respect to x, you determine the value of slope, and you have one point already with you, right? Therefore, you can write the equation of tangent. Therefore, the equation is, what is the equation? When you know one point and a tangent, means this is y minus this point, which is small y. Slope is dy by dx and x minus the point. This is the equation of tangent. Yes or no? Now, very important thing, after knowing the tangent, we can also calculate about the normal, है ना? Given that tangent and normal will make 90 degree to each other, है ना? तो सर यहाँ normal कैसे बनेगा? How do we draw the normal here? This is tangent. So 90 degree will be something like this, है ना? Therefore, I can draw a normal like this. This is normal, and this one is tangent. And I know the equation of tangent, which is here, है ना? Now I want the equation of normal. Therefore, I can use what? A basic logic that slope of both of them, let us say the tangent has the slope m1 and normal has the slope m2. Therefore, since they are making 90 degree, which will result in m1 multiplied by m2 as minus 1 because of their angle. Okay. Therefore, you will get the slope as how much? M2 will turn out to be 1 by minus M1. And M1 value is given as dy by dx. Therefore, it will come out as minus dx by dy. And you have now enough information for normal. One slope and one point. Therefore, you can make the equation y minus this point. Slope is minus dx by dy and x minus this point. And in this way, you can determine the location of, means equation of tangent and equation of normal to any curve. Okay, and I think this everybody must have studied in the elementary mathematics, right? The better or the advanced level concept will be now coming to you. Is it clear? If I draw this perpendicular and give them the name M and this is point P, let's say the center is O and this point of contact to the x-axis is point T, right? Again, so note this down first. The important points you can note. Rest I will send you. Okay. Rest of the notes will be provided to you. So this is geometric application. I think this part is you have noted, right? We are still on geometric application only, but let's write tangent equation. Some important thing is y minus small y dy by dx and then capital X minus the point. Equation of normal. Normal equation is y minus small y, which is point, minus dx by dy x minus. This is the core concept we have studied till now. Therefore, now we are interested in doing what? Determining the length of the tangent. So, next point you need to write is under this geometric only, length of tangent or normal. What is this, sir? This is nothing but I want to determine this length. How much it is from here to here and then from here to here, right? Which I think everybody is able to do it, right? Yes. How to do? I know the location of this point. I know the location of this point, right? I know. Therefore, I can use can use the point formula, distance formula, and I can determine the distance, right? So let us see very carefully. Let us write the location of this point is x2 comma 0, right? Location of this point is x3 comma 0, right? And if okay, listen here carefully. If I know the value of this, then I have 2 points. I can determine the distance, right? If I know this x3, then I will know the point. I have this point already. I can determine the distance. So, how to determine this point? x2 and x3. To determine this point, you can use the equation of this line. To determine x3, you can use the equation of this given line, which is already here. This is the equation of tangent. From here, I will use this. This is for x2. This one will be used for x3. Here, y is equal to how much? 0. And x is equals to x2. Therefore, look at here. Y becomes 0. dy by dx. X becomes x2 and this here. And from this equation, you can easily calculate the value of x2, right? Try doing it and give me the final answer. And I want the final answer. And for this thing also, y is 0, this dx by dy for x3 point. Give me the answer of this x3 and x2. Do it in your copies and give me the final answer. And then we will move to the next part. Okay, anyone of you? What about x2? How much is it? See, this will be just this much, na? Minus y dx by dy, right? What I did? Transfer here and in the bottom, right? Then whatever is in here will become plus, and therefore this is equals to x2, right? What about x3? In x3, this minus and this minus is gone. Therefore, it will be x plus dx by dy into y. Clear? Since now you have the value of x2 and x3, then what you can do? You can proceed and determine the length which we were talking about. Now you can determine those length. So let us say this length is p to t. So pt length will be how much? You will use the distance formula, and how? x2 minus x1, y2 minus y1. So look at here, x2 का आंसर क्या निकाला था अभी? x minus y dx by dy. Check it. Is it correct? x2 minus x1 the square, then y2 minus y1 the square, which gives this has how much? इधर देखो, here cancel out, है ना? like this: y square plus y square dx by dy. है कि नहीं? Yes. Is it looking like this?
Yes, sir.
Yes. Therefore, you can take out y, and this will be 1 dx by dy whole square. This is the length of tangent or normal. This is the length of this PT, right? Similarly, you will find P2 n will be y1 plus dy by dx square. Is it clear? So now, very important thing you have determined, some advanced level thing, right? This length from here to here, this length from here to here. And what you don't need to do is, in the examination, you don't have to make this diagram to determine what? The length of the tangent or normal. You just determine dy by dx at that point, put the values here, and you can directly calculate. And I have given all the logical answers as well, right? Is it clear? So, note this down, then we will move to the next, which is even more important. We are still in the same topic of geometrical application, है ना? Next under that, this is very important, है ना? This is called as length of curve. Imagine this. Look at here. This is a random curve I have given. Okay. This is the random curve I gave you. The name is, let's say, x comma y. Random curve. Now I want to ask you. Look at here. I want to ask you. Give me the length of this curve from this point to this point. I have given you the equation and I have given you the specific points as well, right? Now I am asking you to determine this length, actual length. Is it clear? Which is very tough and which is also similar to determining the perimeter of any curve. Is it clear? Like perimeter of circle, which is known to you. What about the perimeter of ellipse, hyperbola, parabola, or any other curve in this format? How to do it? So, the fundamental concept I am going to give you first. Look at here. See, obviously we need to include differential calculus. Calculus की जरूरत तो पड़ेगी ही, है ना? Simply you cannot calculate also. Therefore, let us consider this distance as dx. The meaning of dx, it is very small, है कि नहीं? And this distance as dy. These are very small that I can consider this thing as ds, where ds is called as, ds you can call as tiny or very small, tiny curve length. Second, here ds is so small that ds is the actual path we are considering, right? Because of the differential property, we can consider it like this. Now everybody knows what thing I can apply and determine ds, which is Pythagoras theorem, है ना? dx square and dy square. You can just apply Pythagoras and determine ds, है कि नहीं? And the complete ds answer, you can just take dx common and it will come out dx like this, and it will be 1 by dy by dx whole square, right? What if I take out, sorry, what if I take out dy common? यहाँ से dy निकाल लिया तो क्या बनेगा? 1 plus dx by dy whole square, and this is giving me the length which is here. This small length it is giving me. If you want to find out the complete length from x is equals to a to x is equals to b, this from here to here, this complete length, then what you can do is use this and integrate it, right? If you integrate this from a to b, then this side becomes s. This is a to b under root 1 plus dy by dx square and dx. So this is the proper way in which you can calculate the length of any curve between any two point. Is it clear? So we will extend this logic and we will do one question and try to determine the perimeter of circle. Okay, then your homework will be to determine the perimeter of ellipse. Is it clear? By using this very logic. समझ आ रहा है ना? You are understanding this, right? Therefore, write this thing and we will be doing one question, that is we will be trying to determine the perimeter of circle. I think this is clear enough, right? How we have used the property of differential calculus here. So, question is, write the question, determine the perimeter of circle. And you don't have the allowance of using simple formula, that is mucked up formula, that we cannot use. We will use this differential property that we have studied, the length of curve. Okay, in this I am giving you the random equation. Look at here, a simple one, x square y square is equal to r square, right? This is the equation of a circle whose center is at the origin, है ना? 0, 0. Is it clear? Now try to make one diagram. This is one diagram. Here is x, here is y, and this one is r, right? Can you see it is a symmetrical one? I can. Therefore, we can use from here to here. We can determine this length, and we can multiply it by 4, है ना? Because of symmetry. Or you can determine from here to here, and you can multiply it by 2. That is also acceptable. है कि नहीं? What is the location of this point?
R0.
How much is this location?
R0.
Okay, and what about this?
-R0.
Here and here also you can determine, right? What about the random point? That we will discuss now, है ना? According to this, what is this S, which is length of curve, है ना? We are starting from x is going from where to where? 0 to r,
0 to R.
and x is going from 0 to r. Inside this, what do we have? 1 plus dy by dx square and dx on this side, right? Right? Try calculating this. I think it is simple enough, right? It is doable. Right. I am solving here. You try on your own. This is 2x, 2y, dy by dx is equals to 0. If you differentiate with respect to x, here you will get dy by dx as this much. Put this here, the value of y. From here, previous y as minus. Currently, we can use the positive value for the first fourth quadrant, 0 to r. This 1 plus here minus of y by x. This will be this xy. Okay. Here the square, this will come up x square r square minus square. Is the answer matching? Look at here. You can follow the integration, है ना? It is coming pi r by 2. Is it clear? Which is the perimeter of how much? 1/4 of the circle, right? For the whole circle, you multiply this thing by 4, and you will have the complete perimeter of circle. You can use this logic and you can come up with the perimeter of any of the curve. Okay? Is it clear? So, this is quite an After this, let us move to the next important thing, which we will call it as radius of curvature. Is it clear? That is called as radius of curvature. By the term, what do you mean by radius of curvature? हमने फिजिक्स में when you were studying mirror and something like that thing, right? Mirror और lens पढ़ रहे थे, then we have heard about this term radius of curvature, है ना? So now here, what is the importance of this radius of curvature? ये है topic. Radius of curvature at point P. So at any point you need to determine radius of curvature. Before that you should know what radius of curvature is. Is it clear? I have given this point A, B, and out of this I am saying point B has higher radius of curvature, means radius of curvature is big and radius of curvature is small. What do you understand by this term? See, radius of curvature tells you about how the curve is bending at that point. Is it clear? How it is bending at any particular point. Here you will find bending property is more and here the bending property is very less, right? Is it clear? Which also gives a number. Radius of curvature is one number which will give approximate value of one circle, that is, that you can make it by using the curve of this location. Is it clear? So here if you use this curve of this point, you can draw this big circle. Okay, so the radius of curvature is this much. Is it clear? Less is the curve, bigger is the radius of curvature, right? And bigger is the radius of curvature, less bending is there. Understood? Here you will find the bending property is more, therefore the approximate circle which is possible here is very small. Radius of curvature becomes small and bending becomes high, right? Is it clear? So when you find, when you are given with any random fxy, how do you determine this radius of curvature? What logic would you apply to determine this radius of curvature? So this was just an example to show you guys, है ना? Can we think, so in solving this problem, can we think like length of the curve? Okay, this is dx. Okay, here is this dx. For the same distance, you are saying x is changing this much, and the length of the curve is this, right? Yes. For same value here, for same change, same x, this is more. Yes or no? Yes. You can clearly see for same amount of change in x, the length of the curve is very high. Is it clear? And can you relate this number with radius of curvature? Since the radius of curvature here is high, R is high, therefore length of curve is also high. Yes or no? Here it is radius of curvature is less, therefore the length of the curve is also less. Yes or no? I will give you one more explanation in which you can understand. Try to draw the tangent here. यहाँ अगर टेंजेंट ड्रॉ करूँ ये आएगा. If I try to draw the tangent here, this is the tangent, right? है कि नहीं? Is it clear? You will see the change in angle is little bit there, है ना? Angle is let's say 30, and here it has become 32 degree. Angle has shifted a little bit. What about here? This. And here is this. You will find the change in angle is very big. Yes or no? Is it clear? So, large is the change in angle, larger is the radius of curvature, and less is the bending of the curve. है कि नहीं? Is it clear? If the bending is too much, then this is the way to determine. So ऐसे कैसे निकाल सकते हैं? You will see. Slope कितना है? Tan theta is equals to dy by dx, right? Is it clear? Now this is also equal to m, right? Now radius of curvature R is defined as, I will tell you, change in length of this curve, change in this tiny curve with respect to change in this angle d theta, right? If this change is very large for change in this, then radius of curvature is very big, right? Yes. And therefore, this is similar to determining acceleration, right? Acceleration is dv by dt. That is predefined. And therefore, this is also defined in this way. Change in this curve as you change the angle. So, as you change this angle, how is this length changing? Will show this value. And how to determine this? ये theta इधर है. So from here you can determine what quantity? d theta by dx निकलेगा. Because theta and this is there है ना. You determine and you will get this value. And after getting this, you already have determined, let us say I multiply this by dx and divide by dx, right? In the next step, very carefully, since I don't know the answer of this is the technique I am using, right, to manipulate. ds upon dx, do I know this? From the previous, है ना? What about this dx by d theta? From this very equation you can generate. So I am writing it like this. Very carefully look at here, na? Look at here. ds upon dx, ये फर्स्ट वाला जो है वो इक्वल होता है about this much, है कि नहीं? It is equal to this much. And when you find this from here, it will come out this d2y by dx square in division 1 plus dy by dx whole square. Is it clear? And after this, you will see this is half power and this is power 1. Okay? So you can remove this thing and you can actually put here 2 the power 3 by 2 है कि नहीं? And this is the formula to determine the radius of curvature, है ना? It will give one value of r, है कि नहीं? This is equal to r, which gives the radius of curvature, है ना? Is it clear? Can you tell me slope कहाँ जा रहा है? यहाँ कि यहाँ?
राइट वाला.
In this the slope is more, है ना? Slope, ये slope दिखा रहा है क्या? है ना? This is showing slope. More is the slope, more is the radius of curvature, है कि नहीं? Less is the bending property, है ना? जितना बड़ा circle, उतना कम bending property, right? More is the bending, less is the radius of curvature, which you can see from here. If this quantity which represents slope is big, then answer will also come out big, है कि नहीं? Is it clear? Therefore, this is the complete explanation of radius of curvature and how to calculate this thing. Okay, I will provide all the notes. The key part for you is to understand the concept, है ना? कि कैसे इतना आ रहा है, क्यों इतना है, and proper explanation behind those, so that you can manipulate this thing in different questions, है ना? Writing work is not that much. I will provide you with the notes. You can do the Xerox. After this, we have finished the geometrical application of differential equation of first order, है ना? Which is required for you. We are done till that. Now we will be moving to one interesting topic, that is orthogonal trajectory. और orthogonal का मतलब क्या होता है भाई, ये बताओ. When two things are orthogonal, the meaning of that, कौन बता रहा है? The meaning of orthogonal, है ना? क्या मतलब होता है ऑर्थोगोनल ट्रैजेक्टरी का? तो जस्ट रीड मीनिंग ऑफ ऑर्थोगोनल. अभी इधर जो नीचे देख रहा है, व्हाट अबाउट यू डोंट नो ना? ठीक है. द मीनिंग ऑफ ऑर्थोगोनल इज व्हेन टू थिंग्स आर परपेंडिकुलर टू ईच अदर, है ना? द अदर टर्म फॉर दैट इज ऑर्थोगोनल. यू कैन से इन सिंपल वर्ड, दिस इज द डेफिनेशन. अंडरस्टैंड? Here orthogonal trajectory means, let's say here is one curve, random curve fxy, then I want to determine another curve which is orthogonal to this curve. Is it clear? So this will be used in your JEE exam also, na? They will say two circles are orthogonal to each other at point P. Orthogonal at a point, है ना? 90 degree they can be at certain point only. Now two circles are orthogonal at 1, 1. The meaning of that is their tangent will be making angle 90 degree. Is it clear? So here if I want to draw this point P, इधर देखो, in a random curve, tangent how it will look like? This is the approximate tangent at point P, right? है कि नहीं? Therefore, the question says determine a curve or a family of curve which is orthogonal at point P. So therefore, you can make a curve in any fashion like this, whose tangent is making angle 90 degree to this, right? So definitely, you will be able to determine this equation, है ना? Because m1 and m2 equals to -1 when you multiply, है ना? So equation तो ये equation तो निकल जाएगा. But what about the equation of this curve? If they ask about this, then how do you calculate this thing? Which procedure I am going to tell you now? है ना? It is simple enough. Just we are doing the backtracking. Okay. So this is our original curve given. Let's say this is original curve, which is in this format. इधर देखो. Function of x, y, and some constant equal to 0. है ना? It will be in this format. Like x square plus y square is equals to r square. है कि नहीं? 2 variable and 1 constant. Meaning of that is this much. You draw it like this: minus r square equal to 0. है ना? X, y, and 1 constant. So this is original curve that we have been given. The question asks, determine determine a curve which is orthogonal to this at particular location, है ना? Location we are not concerned, but we'll see this. Step number 1: make a differential equation in this format: f x y and dy by dx is equal to 0. Is it clear? So what you are going to do here? Eliminate the constant c. Side by side example I am giving: x square plus y square is equals to r square. The differential equation will look like how much? 2x plus 2y dy by dx is equal to 0, है ना? This much. Here you will find that you have only x, y, and dy by dx. Constant part is being eliminated. Yes or no? Then the next part will be replace. It is very easy. Replace dy by dx to minus dx by dy. Is it clear? So here you have what thing you have? क्या है? dy by dx. So erase it and write minus dx by dy. Then solve it to get the required curve. Okay, you can solve this and you will get the required curve. Try doing it. Will it work or not? Let's see. Try doing this and let's see if it works or not. So let us try. Our original curve is a circle, है ना? Let us try to solve this piece which is written here. So 2x plus not plus equals 2 dx by dy. इतना होगा. Then after you can cancel x and this. Then after what you can do here? This will become how much? dy x and y dx, है ना? It will be this much. Then you can सेपरेबल हो जाएगा ना, which will look dy by y and dx by x, है कि नहीं? When you do the integration, make sure to write ln c, है ना? So y is equals to x c, which is the equation of अब देखो ये कैसे बन रहा है ऑर्थोगोनल, how it is becoming orthogonal. You see this, based on the equation of circle, this is x, this is y, this is a circle of equation x square plus y square is equals to r square, right? And you have a straight line which is passing through center, therefore this is diameter only, na? And if you draw this tangent, these two curve are 90 degree to each other. This y is equals to xc and this circle, this line and this circle, they are two curves. They are making how much angle? 90 degree, and therefore at these two particular points they are orthogonal to each other, right? So this is how you determine the orthogonal trajectory. Is it clear? You can determine for any curve of two dimension which is given to you. Is it clear? So yeah, why not to do one more question, ना? एक और क्वेश्चन लगा के देख सकते हैं हम. Find the curve which is orthogonal to x is equals to yc. ये फट से होगा ना? Give me the name of this curve. Means what? Curve. कौन सा curve होगा? Shape of the curve.
straight line. Oh, नहीं.
This is the straight line. I want a curve which is orthogonal to this. कौन सा कर्व होगा? हाइपरबोला, पैराबोला, एलिप्स, सर्कल, कौन सा हो सकता है? At least you know the circle is the correct answer, है ना? You need to check about the others. Other can also be true there, right? But a circle is definitely a correct answer, है ना? You can just proceed and dx 1 dy by dx. I don't think it is required that we solve this. We will move to the next question and we can try to determine. Okay, so try for ellipse. Let's say find an orthogonal curve to x square by a square y square by b square is equals to 1. Determine the curve which is orthogonal to this. Therefore, simply you can do it. करके देखो. And here I am doing this becomes 0, this also becomes 0. I am doing some replacement. Just dx by dy in the place of this. So y b square is equals to minus x by a square. Therefore minus and minus are eliminated. And this is this much. Think. Just shift this b to this side and you have what? dx by x. This is here. B square by a square is there. Here goes d1 comes y. The integration will get x is equals to है ना? You got the similar answer? सही है क्या? है ना? Therefore, what is the equation of this? Based on the power, it can be anything, है ना? Yes. अब देखो इसमें special case of this. When A is equals to B, then it is equation of circle, है ना? This, the equation of ellipse becomes equation of circle, right? Therefore, the orthogonal equation is x is equals to c y to the power 1. It becomes a straight line. है कि नहीं? And the random is given there based on this value. Let's say b by a is equals to 2. Then for ellipse, let's say b by a is equals to how much? 2. Therefore x is equals to c y square. The equation of parabola, है ना? Opening on which side? Y can be plus minus, but x will always be plus. है कि नहीं? Therefore it will open on which direction? है ना? Y cannot be, x cannot be negative, so it will open like this. है कि नहीं? Is it clear? So how does the diagram look like? An approximate diagram for this case, this very case. Ellipse a by b by a is how much? 2 na? B is the y-intercept, right? है कि नहीं? So b has to be twice a. If this is a, b has to be how much? Twice of a. So this is b, this is minus b minus, and this is plus b. Therefore your equation will look, this is the approximate, let's say, way to draw it, है ना? Now give me the equation. Parabola कैसा दिखता है भाई हमारा? How is the parabola looking like? X is equals to cy square, opening in this direction, है कि नहीं? And therefore at this very location they are going to make 90 degree or will becoming orthogonal to each other. समझ आया क्वेश्चन? Understood? Based on the value of b and a, it will depend. And obviously third is physical application. So this class will continue for tomorrow as well. Today the last part is physical application. Under physical application, so second is over. Second one was orthogonal trajectories. After orthogonal trajectories, we are going to discuss physical application in real life. So this is next. Physical application. This we are not going to say that you don't know, okay? You know till depth because मैंने physics में पढ़ा रखा है ना? If there is an object with initial velocity 0, mass is m, and I apply the force, then after time t, the velocity will become v, है ना? And it will cover some distance x. What are the relations you can generate? These are the relations. V is equals to dx by dt, है ना? Differential equation is there one. Acceleration is dv by dt, है ना? और d2x by dt square. Yes. और एक्सेलरेशन को और मैनिपुलेट करके क्या बनाया था हमने, इधर देखो dv by dt multiply and divide by dx dx, है ना। इफ यू कंबाइन दिस टू क्या बनेगा, वेलोसिटी, सो दिस बिकम्स v dv by dx as an acceleration, है ना। So all these properties is known to us, these are not new, है ना। So we are moving a little fast. हमारे पास फोर्स का आंसर क्या होता है, dp by dt, where p is m into v, and you apply the chain rule, you will get m dv by dt or v dm by dt, है ना। Therefore this is what force we have studied in physics, है ना। NLM के स्टार्टिंग में मैंने ये सब पढ़ाया था ना, is it clear? Therefore we can do one question, है ना, then we can finish. एक क्वेश्चन करो, it is under this only, write down the question. A boat is rowed, R-O-W-E-D. A boat is rowed with a velocity of u, with a velocity of u directly across the stream, directly across a stream of width a, of width a, full stop, full stop. If the velocity of current, if the velocity of current is directly proportional to the, if the velocity of the current is directly proportional to the product of the distance, is directly proportional to the product of the distance from the two banks, from the two banks, full stop. Find the path of the boat. Find the path of the boat and the distance downstream, and the distance downstream to the point where it lands, and the distance downstream to the point where it lands. First, before attempting, try to read this once more, है ना, और समझो क्या बोल रहा है। अब मैं सॉल्व कर रहा हूँ, तो इधर ही देख लो तुम, पढ़ो और इधर देखो, है ना, पढ़ो पहले, then you see this. So this is the river according to the question, है ना। According to the question, this is the river whose width is how much? A, है ना। So I can consider this as y-axis and this part as x-axis, है ना, ऐसा मान सकते हैं। अब according to the question, it is moving with the speed with u directly across the river. ये sentence पढ़ा। After reading this sentence, you should have the clear idea he is talking about this velocity, right? This velocity is u, and the river is flowing in this direction. I have taken river is flowing in this particular direction, है ना? So say is v of x, है ना, and this is velocity in y direction. So based on the question you will find how much is vx. अभी बताते हैं. Vx is directly proportional. Vx is directly proportional to the distance between both the banks. ये word पढ़ा. So imagine he is going in this path. I don't know, है ना? I don't know the path. Let's say this guy is here. Then very carefully. This velocity is remaining u only, okay? But this side velocity, this is Vx, is depending on the distance between both the banks, है ना? So distance between from here to here, let's say, is y, and distance from here to here will automatically become a minus y, and the velocity depends on the product of these two numbers, है ना? So look at here, velocity x is proportional to y and a minus y having the product, है ना? I can remove the proportionality constant by applying a constant k. Is it clear? Now you have what it takes to solve it, because you can now apply this and determine the total velocity, है ना? इधर भी देख लो carefully. Vx can be written as dx by dt. Vy can be written as dy by dt. And the y direction velocity is how much? Equal to u, and it has told me to determine this thing. Now this is clear now. I am erasing it now. See, definitely this is not going to take straight path, है ना? It will take some random path like this. Then I want to determine this deflection. ये भी पूछा है ना? And they have asked about the shape. They have not asked about how much time he will take, है ना? Time तो बहुत easy निकल जाएगा ना? A by u will give you the time, है कि नहीं? Which is not required. अब देखो यहाँ I want the shape. ये shape चाहिए ना? This shape is relation between x and y. Can you make relation between dy and dx? Just divide both of them and you will get dy by dx. dt cancel out. It will be u upon ky ay, and again you will come to know you have made a differential equation which can be, कौन सा फॉर्म है ये? यस, वेरिएबल सेपरेबल फॉर्म में आ जाएगा. ky ay dy u dx. Now I am leaving this to you to solve. You can do direct integration here. You can determine the value of whatever you want, है कि नहीं? Is it clear? You put this value a and you will get this d answer very easily, है ना? Is it clear? So in today's class we will be discussing this much only. In the next class we will discuss, okay? So be seated. We will see what we are going to discuss in the next class, है ना? सर्किट एप्लीकेशन, LC, LCR, पैरेलल सीरीज, ये सब सर्किट पढ़ा है. So we will be discussing everything related to that. When you apply DC voltage or AC voltage, how should be the graph? ये हर चीज डिटेल में देखेंगे. Then second we will study about Newton's cooling curve, है ना? Then after we will study next radioactivity decay. Is it clear? Then after we will discuss flow of heat. Heat flow है ना? How the heat flows. That is also in your syllabus. And maybe we will see something related to chemical reactions as well. Is it clear? है ना? Physical part में जो chemical reactions है ना, rate of reaction and all those. The simpler part, right? Which involves differential equation that we are going to discuss in the next class. And after discussing this much in tomorrow's class also, you will finish the chapter of application of differential equation of first order. Okay, the application of second order will be still remaining, which is your SHM